Aniketos is a tool made up of 4 software packages: the Socio-technical Security Requirements, Secure Service Specification and Deployment, Security Service Validation and Verification, and Security Monitoring and Notification, each of which perform a task and address specific needs, from the requirement specification to design to the execution of software. The Socio-technical Security Requirement package allows for the modelling of complex security requirements. The Secure Service Specification and Deployment package transforms the socio-technical specification into a secure composite service specification. The Security Service Validation and Verification package determines the validity of the composite service specification and its contracts, as well as ranking potential composite services by characteristics such as confidentiality and trustworthiness. The Secure Service Specification and Deployment package allows the composite service to be bound to contract and threat monitoring and deployed on the Aniketos activity engine. At runtime, the Security Monitoring and Notification package allows the Aniketos platform to respond to changes and threats in the environment and violations of contracts specified at design time.
STS tool is a security requirements engineering tool for secure socio-technical systems. As such, it is suitable to capture security requirements for composite services. STS tool is a standalone application built on top of Eclipse and is available from download from sts-tool.eu. STS tool supports multi-view modeling to capture stakeholder security requirements for the system to be, capturing stakeholders, their interactions and security needs in the social view, information ownership and information representation via documents in the information view, and finally, permissions over information in the authorization view. Once the modeling is done, STS tool allows the automatic derivation of security requirements. The tool allows the generation of a security requirements document describing the various views and the list of security requirements, among others. Finally, STS tool allows automated analysis over the created models, starting from consistency analysis, which allows to perform well-formedness checks over the models, to security analysis, which identifies security requirements violations, and last but not least, risk analysis, which calculates the impact of threats over stakeholders' assets. This is the final version of STS tool, version 1.3.3.
We will now demonstrate the strengths of the Aniketos platform by creating a hotel booking service composition, using the Aniketos service composition framework to design the service and the Aniketos runtime environment to host and dynamically recompose the service in response to changes and threats. In the Aniketos platform, services are created as projects within the service composition framework, an extension of Activity Designer. The Service Designer fills this blank canvas with the elements of their composite service. They place and connect BPMN elements to represent the start and end of their composite service as events, invocations of other services as service tasks, and the logical flow of execution in their composite service as gateways. In order to run the composition plan, the signature of each service task must be defined. In the Aniketos platform, we can achieve this in two ways using the Aniketos marketplace. The first way is to specify a service type and signature using a taxonomy agreed between service designers and service providers. The second way is to select a service category using a type cloud integrated in the service composition framework. The Aniketos platform enables the specification of security and trustworthiness requirements that constrain the composite service during the design and runtime phases. For this demonstration, we place a trustworthiness requirement on the map service in our hotel booking composition. This constraint specifies that we will only permit those services with a trustworthiness of at least 7 to fulfill the functionality of the map service in our composite hotel booking service. The service composition framework includes tools that automate and assist the generation of policies from the security and trustworthiness requirements. The Aniketos platform assists the service designer by automatically discovering services that meet the signature of their tasks in the Aniketos marketplace. The Aniketos platform creates and ranks concrete instances of the designer service composition that meet their security and trustworthiness requirements, allowing the designer to select their desired composition plan. The final stage in the process enables the designer to deploy their service in the Aniketos runtime environment and the Aniketos marketplace. To start the process, the user completes the reservation form. Submitting the form will trigger the execution of the Composite hotel booking service. The Composite service completes and confirms the hotel booking and displays a web page with a map identifying points of interest near the hotel. An email is also sent to the user confirming their booking. For this instance of the Composite hotel booking service, the map information is provided by Microsoft's Bing. To demonstrate the strength of the Aniketos platform, we will now simulate a decrease in the trust level of the map service by sending a platform notification. This will invalidate the trustworthiness requirement that we specified at design time, triggering a dynamic recomposition that will replace the composite map service with one that meets our requirements. Now, when the reservation form is completed again by a user and is submitted to the composite hotel booking service, the new, trustworthy instance of the service is executed. For this new, trusted instance of the composite service, the map information is provided by Google. And, as before, a reservation email has been sent to the user.
For this part of the video, we're going to be looking at the Secure Service Validation Verification package. This package works in conjunction with the other three Aniketos packages, but especially the Secure Service Specification Deployment package, which you'll have just seen being used to specify a service description. And in fact, we're going to use the same user interface as the Secure Service Specification Deployment process. The verification and validation process is used by the service developer to make sure the final result satisfies the security requirements that they want, and also at runtime in case a security property is violated. In that case, the service may need to be automatically recomposed or reconfigured to fix the problem. So we've already had two service compositions generated based on the services that are available in the Aniketos marketplace, and as a service developer we want to know which of these best satisfies our security requirements. The security requirements themselves are created using Conspec, the contract specification language, and we can input them using the Conspec editor as you can see here. Now Now, rather than input by hand, I'm actually going to load in a contract which was created earlier. Here we go. So the contract you can see here is actually a confidentiality requirement. It specifies that the services in the composition have to satisfy various encryption requirements. They have to communicate using encrypted communication in order for them to fulfill the requirements. This is a confidentiality requirement. In addition to this, the process also currently supports several other properties, including separation of duty, binding of duty, dangerous Java function analysis, and trustworthiness. So once the service developer has created their service plans, their service compositions, and specified their security requirements, they then want to know whether or not the compositions actually satisfy the security requirements. So for this, we use the Secure Composition Planner module that you can see here in the bottom left-hand corner of the user interface. And all I have to do as a service developer is click on the Verify All button, as you can see there, and that's going to now send the services to the Aniketos Cloud Analysis services in order to check the security requirements. If I have a look at the console, we can see that this is actually the remote analysis going on the remote server. Now that's going to take a little bit of time, so we're going to skip past that and have a look at what the result is when it comes through. Okay, so the verification process is completed, and we can see the results have appeared in the table here on the left hand side. If I select these and hover over them, we can see the results. So in this case, there was a contract matching error. That's because we didn't specify an agreement template. However, we can also see that it actually passed the verification check, so this service composition fulfills our security requirements. If we have a look at this one here, we can see that it actually failed the security requirements, and so we wouldn't want to deploy the service. However, in general, we may have many more services that are checked, and there might also be many more that satisfy the security requirements. And in that case, we'd still want to know which one was the most appropriate, which one, so that we could make a choice of which one to deploy. And in that case, we could use the order and ranking capabilities that's also part of this package. So from here we can set up our user preference for which criteria are most important for the security ranking. And we can choose here, for example, from trustworthiness, credibility and validness. We're going to set these two down to 0 and base all the requirements on the trustworthiness, and then click on the order ranking button. And again, the details get sent to the Aniketos Cloud Services, and the result comes back and is displayed in the user interface. Okay, so here we can see the result. This table is now ordered based on which services satisfy our requirements best, and we would choose the service that best satisfies our requirements to deploy to the cloud.
The security and monitoring notification component of the Aniketos platform allows Composite services to dynamically respond to contract violations and changes and threats in their environment. In this section of the video, we will show how the Aniketos platform monitors and responds to violations in separation of duty and binding of duty contracts. We begin by hosting a local version of the Aniketos platform and its components for this demonstration. We then open a graphical user interface that allows the demonstrator to specify which contracts to monitor on the Composite service. The Aniketos platform is now monitoring for violations of the separation of duty contract on a Composite point of interest service. In the console window, we can see the monitoring component responding to inputs from the user in real time. In this case, as the map and point of interest service are provided by the same service provider, the contract has been violated. This resulted in a notification to the Aniketos platform, which will respond by dynamically recomposing the service in the background. We will now look at the violation of a binding of duty constraint on the weather forecast and map services in the composition. This time, we can see that as the weather forecast and map services are provided by different service providers, the contract is violated, and again, the Aniketos platform will respond by dynamically recomposing the service. And again, a notification has been sent to the Aniketos platform.